Hello and welcome to this installment of Step by Step with Henry. Today we're going to do an overview of the ADO.NET data reader, and specifically we're going to talk about how we can make a do-it-yourself Dapper, if you've seen the Dapper video that we did, that converts an ADO data reader object into a list. An overview of ADO.NET says there's basically two ways that you can work with ADO. Either as a data set, which is that big thing at the right, very sophisticated, very powerful, and it's also a topic for another day. Here, we're going to talk about the data reader and how we use it to, well, one, feed a data grid or a list view in passing, but also to move its rows of data into a list, just like we did with the wrapper we saw in as we did in the Dapper 101 video. Okay, there's a lot of simple steps in using a data reader. And we're going to go through this in PowerPoint because it's easier to see it conceptually and then you don't get lost in all the little curly braces inside the code. Okay, simply conceptually is you got to define a query string, like select the top 100 asterisk, meaning all the fields from customer where zip code like 60601, or select all the orders from the select all the fields from the order table where customer ID equals Admiral Tool, something like that. Then you're going to need a connection string. Connection string is your server equals, your database equals. In this example, we're going to be using a SQL server. You need a connection object. It's just the connection and the command are just part of the way ADO works. And so you create it and it says, okay, I need the connection string. And then you instantiate it with a command object. Finally, you open the connection and then you use the data reader that says, hi, building on what we've done, I want to take a command, I want to execute this thing called the ADO reader using the connection object that uses a connection string, etc., etc. And then it moves all the data into the reader object. Okay, from here, you have this reader object, which is all your data. You can just pass the reader object to a control that knows how to process this object, as in mygridview.dataSource equals reader, and you're done. Or you can process and store the elements individually, like in a list, because the data reader is a forward-only entity. You cannot go back and forth in it. In this video, we're going to show you how to store this in a list object where, like the Dapper example, each element in the list is an object that represents a single row in the data table. Okay, conceptually, this is pretty straightforward, as the only little thing you need to do is to cycle through each property in your list, call it, customers, and grab and transfer the corresponding element from the reader, as in customer.company name equals the reader of company name. And the reader does know how to read in the schema, so if you say I'm looking for a field called company name or address, it says, oh, that would be index number 7 or 3 or 0 or 1 or whatever. So we can use that. Life is looking pretty good, except there's two pesky little details that we have to overcome. The details are, one, we have to be able to cycle through and read the property names of the object. Company name, company address, city, state, and zip, etc. And then we need to do a convert to string or integer or whatever individually on each property or field, as there's no implicit type conversion. So while something simple like write line to the console, reader brackets, quotes, company name works and it knows how to just grab it and send it to the screen, something which would seem as intuitive as customer.company_name equals the reader of company.name that you were able to send to the screen generates an error that says, nope, the two types aren't equal. You have to basically do a convert to on each and every single line. Okay, with this overview as our guide, we're going to tackle the problem. The details get a little complicated about cycling through and the convert and etc. But if you keep each section in context with the above, these basic building blocks aren't that hard. To quote Nobel Prize winning physicist Richard Feynman, when you understand the concepts, you don't have to memorize the details. That's what this handbook example is for, to give you the details so that you don't have to memorize them, just understand the basic concepts. Okay, let's go look at the code. Okay, we're going to do a very quick overview of the code here, and then we're going to run it real fast to show you the output and a little bit of the timing. In general, if you remember our PowerPoint slide, okay, we have a step 0 that says we're going to create a list object to hold everything. In this case, it's customers, which if we look at our customers class, we find out that what customers look like is this. Right now, we just have approximately 15 fields in the customer file, not a whole lot. So we just define a list as a new list of customers. Okay, we create the connection string. In this case, we're going to take the top 100 fields, which default to asterisk, and we're going to do it from database customer master. FA is the prefix for flex account, where, and again, we're going to take a where clause just arbitrarily, and just for demo purposes, we'll have customer ID begins with the letter I, and order by customer ID. We make a connection. Got a connection string. If you remember the Dapper video, and we'll show you again, we make a little helper thing that calls in this little resource that says, just go out to the app.config, find me a tag that says flex, and give me the connection string. Okay, take that, and we open the connection object, which is here. It then takes the connection string. Pretty straightforward stuff. We're already up to 3A. Use the connection to make a command. The command, you then open the connection. The connection then is used to execute the reader. And these are the 4 steps that we saw on the PowerPoint slide that says, this is how you open the reader. Okay, pretty straightforward. And now if we wanted to just assign this to the data source of something like a grid or a list view, we could be done. Now what we're going to do is just cycle through the reader, which is to say we're going to go through this loop, kind of like a do while not end of file, but it's going to implicitly just read a row from the prescribed data source every time it loops through here. Going to put everything in a try-catch block, of course. And basically, we're going to populate the customer one customer at a time. Remember, we're here basically to store each element so we can process it in a list as opposed to the reader normal read object that says, nope, you can dump me over, but you can't go backwards and forward me. I'm not an in-memory record set. So we create a new instance of the customer, and we then proceed to fill its values, and then we'll add it to the list. That's pretty much it. So we have a new object called current customer, and it's going to be of class called customer. Recall that customer is just that guy right there. And we say, okay. Now, we do this if false. This is just here for debugging. It says, ultimately, this is what we'd like to do, except we need to do it literally. When I say something like current customer.igrin, which is the index number, the integer global row identification number, is got to be converted to an integer 32 as you read in from the reader the quote igrin end quote entity. So it knows it by name. But as we said in the PowerPoint, you can't just assign it and assume that it knows how to figure it out. You need to take whatever the heck format object comes in from the reader and tell it, I need you to convert me into an integer 32. For all the other values, similarly, if it's a customer ID, which is a character string, that has to be converted to a string from the reader, quote, customer ID, end quote, etc. And that's just the example that we commented out because we put in there during debugging. Okay, now comes the magic. We cycle through each property and set its value from the data reader. To generically cycle through it, we need 2 things. We're going to need the name, like IGRIN, company ID, address, city, state, and zip, and we're going to need its type because we have to know whether we have to use a convert to int 32, to date time, etc. That's where the unfortunate part comes in. For temporary purposes and just making life a little bit easier, we create dummy variables like current property name and current property value just because they make the debugging easier and expands it to be a little bit more illustrative. In the real code, you could probably skip it and save yourself 1 or 2 milliseconds. Okay, now here's the part that says, wow, that certainly wasn't obvious, or if it was obvious, you certainly don't need this video. It says, okay, we need to cycle through the properties of this current object, which is the customer. And the syntax is for each variable property in current customer get type get properties, that is going to basically put the property, which is to say each one of those guys, it's going to cycle through those. We have a property counter, again, just for debugging and just for our own edification as we're going through this. We create a thing called property name, again, because we're going to end up using it, but we could substitute in prop.name each time, and it would be just as equivalent. It's sometimes a little bit nicer to have it here. Personal programming style. Now, here's the hard part, is we need to get the exact type, and that wasn't obvious to me, is that line right there. Nullable get underlying type, open paren, prop.property type. There. Cur type, if you end up hovering in debugging mode, will be something very large, like cur type equals name int 32, full name system int 32. Okay, we now have the raw things that we need. The property name, which will be used because we know how to tell the reader what it is, the field it is that we want to read, and the current type, because based on the current type is going to be whether we do an int32, an int16, to string, to single, to double, etc. In some respects, we're almost done. A whole bunch of if statements instead of a switch case, but basically we say, okay, now that we know the name and we know the type, we would like to say if it's a type of int32, which by the way, could also have used this syntax up here, but if you're a type int16, then we want to move your prop set property value of the current customer that we're cycling through, and we're going to convert it to an int16 of the property name. Okay, if you understand that, we're pretty much done, because do the same thing for pretty much every other data type. There are approximately 11 convert tos, and each one of those is represented here, and that's pretty much all we do. And for debugging purposes, just set this in. We say, by the way, what is the current property value? And we want to make sure that, gee, it's not blank, it's being set, and we can put a breakpoint in there if we wanted to. Here's our catch for the each property. And then we're now done with the for each at this line 188. We say, okay, we've gone through each of the, what in this case is about 12 properties, which is to say field names for the current customer. We're ready to move on. So we just add that to the customers list with the current customer that we've been populating all this time. And we're done. We have a catch, which is for the reading of the individual rows. And finally, we close out the using statement, which as you recall, is the connection is stored in the using statement, not the directive using statement, so that the connections and all the resources are closed as soon as we're done with it. We have now stored everything that we wanted to memorize into the customers list, and so now we can close the connection and say, fine, we're going to do everything we want with the customers list. First, we do a quick little literal run through, and we say, okay, we're going to create a variable called output line, and we're just going to do the line number, the integer global row identification number called IGRN, customer ID, ship to ID, and company, and then new line. And then so for each customer in the customers list, we're going to say, fine, I already know your field names explicitly, so all I need to do is go into each customer and say the output line is going to be whatever it was concatenated with the row counter plus the ID, the global row identification number, customer ID, ship to, company, and new line. Just going to output that. That's it. Now, we happen to have a little helper file that says, okay, I need you to take this string and I want you to write it to a file, just basically saving us the data IO. It's a relatively simple 2 or 3 line program. And here we go. I'll show it to you real quick. write to file. Make sure you have a file name, does an output to file name, closes it, and it says, do you also ask if you wanted to open it? It says, oh, well, we'll do a process start. So in the case of, for example, a CSV, it says, oh, I know that invokes Excel when I see a CSV file. How nice that is for us. Okay, that's it. And then we do something a little bit more complicated. So that's okay because it gets a little nesting and sometimes a little confusing. Now that we did it where we literally knew what the properties, which is say the column names were, let's do it one more time where we're going to ask it to do all of the columns, which is to say properties of customer, on its own. And so we have for each basically row, and I think of this list of customers as a kind of like an in-memory record set. And so each row, we're going to say now for each column, and it outputs it. So, by the way, if we're on row number 1, let's also create a separate variable called column headings, which will prepend to the beginning so that we get nice little column headings. Okay, that's it. The only thing we need to do now is we'll just run it and show you how quickly it runs. And put that in view. It turns out that we hooked this up to the search button. We'll eventually hook it up to all the grids that you saw before, but while we're in testbed mode, we're just going to run it by hitting the search button. Click, and that comes the first Excel spreadsheet, and now comes the second Excel spreadsheet, and that's how quickly it returned the list. Here's one where we explicitly enumerated what we wanted the column fields to be, and here's the one where we said, no, just take everything that you imported and give it to me. Date modified, etc. Widen the fields. Oops. There we go. So it's all in there, and we didn't do any particular date checking or data checking to make sure that the comma separated values didn't have any embedded commas or the other kind of things that when converting text into a CSV file gets a little confusing. But the idea is just these loops, and that is how we now create a basically do your own Dapper by using ADO.NET. The list object here that we created is indistinguishable from the list object that we created in Dapper. Having said that, there is one thing which I have yet to do, which is the fact that here, unfortunately, editor's note, that we create the object here and we create the object here, that we need to pass that in. So it's a subroutine, can't be hardwired for each individual class. We need to pass that in. I've yet to work on that, but I'm just so happy that I got this far. I'm just documenting this. Okay, that's it. Thank you very much.